Welcome to the Chapter 6 Part 3 video where we're going to be looking at adding and subtracting with radicals. And before we can do that, we need to be able to recognize what a like radical is. So like radicals, just like terms, in a like term, you have to have the same variable with the same exponent, right? So like terms, if I have something like 3x plus 5x, I can combine those to be 8x. But if I had 3x plus 5x squared, I can't combine those. Those are not like terms. So the first thing I want you to do is think about what is an example of a like term or a term that you can add to 5x squared and simplify it. So give me in the chat or in the Edpuzzle an example of a like term to 5x squared. Like radicals are very similar in the fact that they still have to match in order to add them together. But instead of matching variable and exponent, we're looking at index and radicand. So the index, remember, is kind of like an exponent. So we're still looking at having the same power. And then the radicand, sometimes it will have a variable, sometimes it has a number, but either way, it still has to match. So some examples of like radicals, the square root of 2 and 3 times the square root of 2. So think about the square root of 2 as being your variable. The cube root of 7 and the cube root of 7 match. So then I can do 1 minus 5 is -4. Okay, this is very closely related to when we were factoring. When we had something like AB plus BC, we can factor out the B times A plus C. Well, we're doing the same thing here, except our b is a radical. So we have 1 times the square root of 2 plus 3 times the square root of 2. That's the square root of 2 times 1 plus 3, or 4 times the square root of 2. Okay, so we're combining like terms, but now our like terms have radicals, and those radicals have to be identical. The square root of 5xy, square root of 5xy. Cube root of 9x squared y, cube root of 9x squared y. So an example of non-like radicals, I cannot combine if I had the cube root of 9x squared y and the square root of 9x squared y. The radicands are the same, but the indexes or indices are different. So I cannot combine these. Same thing goes if I had the cube root of 9 plus the cube root of 9x. The indices are the same, but the radicands are different. Yes, they both have 9, but one of them has an x and one of them does not. So like radicals means it's the same index and the same radicand. So when we can identify our like radicals, then we can add and subtract. So in order to simplify radicals into a single term, they must be like radicals. Can we simplify the square root of 2 plus the square root of 3? Our first question is the index. And for both radicals, the index is 2. That's fine. Our second question is the radicand. And our first radicand is 2, which is not the same as 3. So no, we cannot combine these. Okay. The most common mistakes that I see are trying to combine the same index but different radicands, because we do have some scenarios when we can combine that. If I had the square root of 2 times the square root of 3, same index, so we can write this as the square root of 2 times 3, or the square root of 6. Also, if I had the square root of 2 divided by the square root of 3, then I can write that as the square root of 2 over 3, which of course we would then have to rationalize, but we can combine those. Okay, but we cannot combine the square root of 2 plus the square root of 3. So I want you to take a look at these errors. Both of these have a mistake. And in Edpuzzle, I'd like you to tell me what mistake was made. On the first one, instead of adding these, we saw this on the last slide I just showed, The square root of 2 times the square root of 3 would give me the square root of 6. So that's the wrong operation. And then in the second one, we tried to combine unlike radicals. We said the square root of 2 plus 3 is the same as the square root of 2 plus the square root of 3, which is not true. Let me show you an example. If I have the square root of 4 plus the square root of 9, I want to say, is that equal to the square root of 4 plus 9? Well, we know the square root of 4 is 2, and the square root of 9 is 3, so that's 5. And I want to know, is that equal to the square root of 13? 13 is not a perfect square, but I do know that 5 is the square root of 25. And I can see that that's very different than the square root of 13. So this is an example that shows you that this doesn't work. Okay, we cannot combine two radicals unless, over addition, unless they are like radicals. So let's look at some examples. What is the simplified form for each expression? We have 3 times the square root of 5x minus 2 times the square root of 5x. I'm looking at my radicals. They are identical. Square root of 5x, exactly the same. So then I can say this is 3 minus 2 times the square root of 5x, which is 1 times the square root of 5x, which we just write as the square root of 5x. In our next example, we have 6x squared times the square root of 7 plus 4x times the square root of 5. Square root of 7 is not the same as the square root of 5. These are not like radicals. I'm still going to check if the radicals can simplify. 7 and 5 are both prime, so that is the simplest form we can make it. We cannot combine those because they are not like radicals. And then in number 12, or in part C, we have 12 times the cube root of 7xy, cube root of 7xy, minus 8 times the fifth root of 7xy. Even though those radicands are the same, the indices are not. So again, these are not like radicals. And that means that we cannot combine them. I'm going to check if either radical can simplify. 7 does not have 3 common factors, x and y same, and then that means we're definitely not going to be able to take the fifth root of that. So that is the simplest form that we can have. Okay, I have a few for you to try here. Go ahead and try these and I will show you the answer. In part A, we do not have like radicals, so our answer, the simplified form, is just the question itself, the same presentation, 7 times the cube root of 5 minus 4 times the square root of 5. In part B, we do have like radicals, so we can add their coefficients. 3x plus 4x is 7x times the radical, which is the square root of xy. Go ahead and pause it if you want more time to look at this. In our next example, we want to find the simplest form of the given radical expression. The first thing that I notice is these are not like radicals, but they can be simplified. So if I have the square root of 12 plus the square root of 75 minus the square root of 3, 12 is 4 times 3 and 4 is 2 times 2, so that's 2 times the square root of 3. 75 is 25 times 3 and 25 is 5 times 5, so that's 5 times the square root of 3. Don't forget your plus minus the square root of 3. Now they are like radicals. So now I can do 2 plus 5 minus 1 all times the square root of 3. What I'm doing here is I'm really factoring out that square root of 3 from each term. 2 plus 5 is 7, minus 1 is 6 times the square root of 3. Okay. In our next example, we're looking at multiplying when we have addition. So you saw one on your last Math Excel assignment where you had to distribute. Now we're looking at FOILing, distributing more than one term. The same process as before, but now we have radicals. So let me write first, outer, inner, last. First is 4 times 5, which is 20. Outer is 4 times the square root of 2. That's 16 times the square root of 2. Inner, that's 2 times the square root of 2 times 5. We saw this in our last class. The 5 and 2 are not in a radical, so they stay outside of the radical. The square root of 2 can't be simplified. And then we have 2 root 2 times 4 root 2. That gives me 8 times the square root of 2 times 2, which is really 8 times 2, which is 16. So if we combine all of those, we get 20 plus 16 root 2 plus 10 root 2 plus 16. Now I can combine like terms. 20 and 16 is 36. And then I have also like radicals, so that's 26 times the square root of 2. Let's try another one. So we're going to do the same thing. I'm not going to write it out as FOIL this time. I have 3 times 5 is 15. 3 times the square root of 7. So that's plus 3 times the square root of 7. Negative square root of 7 times 5. So that's minus 5 times the square root of 7. And then negative square root of 7 times square root of 7. So I have 15. These are like radicals. So that's minus 2 times the square root of 7. And then square root of 7 times the square root of 7 is 7. So that's minus 7. 15 minus 7 is 8, minus 2 times the square root of 7. Okay, all we're doing is distributing, simplifying, and combining like terms and like radicals. So there's kind of an extra step compared to when we normally distribute. Normally we distribute and simplify. Now we're distribute, simplify, and check for like radicals. Okay, I have a couple for you to try. Go ahead and try these, and then we will go through the answer together. Okay, so here we see in our first example, we need to simplify the radicals. This is a cube root, so we're looking for groups of 3. When we simplify them, they all have the like radical of the cube root of 2. So we can add and subtract the coefficients to find 6 times the cube root of 2. In the second example, we need to distribute or FOIL. So we get 6 plus 4 times 3 is 12. So 12 times the square root of 5. 2 times 2 is 4. So then plus 4 times the square root of 5. And then we have our 2 radicals that we multiply. I'm going to multiply the 2 and 4 on the outside of the radical, and then square root of 5 times the square root of 5 simplifies to just 5. And then combining like terms, we get 46 plus 16 times the square root of 5. Go ahead and pause the screen if you want a little bit more time. Our last topic is relating to conjugates. So remember conjugates from our last couple chapters. Conjugates are when we have the same 2 numbers that are added and subtracted. So a plus b and a minus b. Sometimes those are complex, in which case we can write them a plus bi and a minus bi if they're complex. Okay. So what is the conjugate of 5 minus the square root of 7? All we're doing is changing the subtraction to addition, so that becomes 5 plus the square root of 7. Okay, and then we know that when we multiply conjugates, something interesting happens. Specifically, when we multiply conjugates, the middle terms cancel out. Now in our case, the middle terms are going to be the ones that have a radical. So let's try this. 5 minus the square root of 7 times 5 plus the square root of 7. That's a multiplication, not an x. So we're just doing like we did in the last example. We're going to multiply. So we have 25 plus 5 times the square root of 7 minus 5 times the square root of 7 minus the square root of 7 times the square root of 7. So we have 25. My middle terms cancel out, minus square root of 7 times the square root of 7 is 7. And so we're left with 18. So notice we went from something that was irrational. We multiplied by the conjugate to get a rational number. So we went with something from something that has a square root to something that does not have a square root. And this is our second kind of look at rationalizing when we have radicals. So when we have a radical in the denominator, we never want to leave it there. Last time, in the last lesson, we were looking at what if it's just a radical? And we looked at both square roots and cube roots. Now we're saying, well, what if it's not by itself? What if I have a binomial, two terms in my denominator? Well, the way that we are going to look at that is we're going to first find the conjugate. So the square root of 5 plus, instead of minus, the square root of 2 is the conjugate. So I'm going to multiply by the square root of 5 plus the square root of 2. That will make our denominator rational, but we cannot multiply by whatever we want. We can only multiply by 1. So we make it a giant 1 by putting the same thing in our numerator. Remember, this is a binomial. So put parentheses around it so that you don't forget to distribute. So what we have in our numerator, we have 3 times the square root of 2 times the square root of 5 plus 3 times the square root of 2 times the square root of 2 divided by square root of 5 times the square root of 5 is 5 plus square root of 5 times the square root of 2 minus square root of 2 times the square root of 5 minus square root of 2 times the square root of 2. Now we know the middle terms will cancel out. So simplifying again, 3, if I have square root of 2 times the square root of 5, they have the same index. They don't need to be like radicals to multiply. So this is the square root of 10 plus 3 times square root of 2 times the square root of 2 is just 2 divided by 5 minus the square root of 2 times the square root of 2, again, is just 2. So we have 3 square root of 10 plus 6 divided by 5 minus 2 is 3. We can simplify this. 3 square root of 10 over 3 plus 6 over 3 reduces to square root of 10 plus 2. If you prefer to write your radical last, you can say 2 plus the square root of 10. Neither one is more correct than the other. They are equally correct. Okay, so steps that we looked at. First, we found the conjugate of the denominator. Then we multiplied by a giant 1. That required distributing and being very careful with our radicals. Then the rest is just simplifying. Okay, I have one for you to try. 2 rather for you to try, and then we'll go through the answers. All right, so again, the first step is to find the conjugate. Our conjugate for part A is the square root of 3 plus the square root of 5. Distribute, because these are our radicals are being multiplied, then we can combine them. If they're being added, we need to make sure they have like radicals. So in our first step, we can multiply square root of 7 times the square root of 3 is the square root of 21. But then in our next step, we cannot combine those because they are not like radicals. But then we simplify and we end up with negative square root of 21 minus the square root of 35. In part B, our conjugate is 3 plus the square root of 6. Again, distributing, this time we have an x, that's fine. We distribute it just like we normally would with an x. And then simplifying, and then dividing, simplifying our fraction. Our second fraction does not simplify, so it stays as a fraction, and we get 4x plus the quantity of 4x times the square root of 6 over 3. Okay. Pause the screen if you'd like a little bit more time. I have some practice problems for you to try at home. There are 7 here. They are not involving rationalizing, but we will practice that again together in class. Okay, if you have questions, as always, please feel free to email me.